Hello everyone, this is Christine Halsey, and today we're going to look at analyzing the application and transport layers. So I've downloaded PT Skills 4 from my course shell, and I have it up and running here. If you don't have Packet Tracer on your computer, you can go to the lab.devry.edu, log in using your DeVry credentials, launch Packet Tracer, and when it comes up, log in using your NetACAD credentials. We have 4 objectives here: configure host and services, connect and configure host and services on the model of the lab network, explore how DNS, UDP, HTTP, and UDP work together, and use the simulation mode to visualize the operation of DNS, UDP, HTTP, and TCP on the model of the lab network. Here's all our IP addresses and subnet mask and even the default gateways for devices that we're going to configure. Okay, so we only have 2 tasks. Seems pretty simple, but it's going to encompass everything we've learned so far, so it is going to take a little bit of time. The server has just been replaced. We're going to configure it with the following settings. Okay, so we're going to click on the Eagle server. And you can go to the configuration tab, but it's going to tell you have to power on the device. So you'll come back and turn, this is the on-off switch. If you need to, you can actually zoom in. And there's your on-off switch, so we're going to click it to turn it on. Then we can go into the configuration tab. Under settings, we can put in the gateway 192.168.254.253. And we're going to go to services, DNS, turn on DNS service. Give it the association of eagle-server.example.com. And then we have to put in the server's IP address, which is 192.168.254.254. Okay. Okay, also on my configuration tab under Fast Ethernet, I'm going to come in and set up my IP address, 192.168.254.254, subnet mask 255.255.255.0. Okay, I think I got in. I did not enable HTTP, so let's come back to services, HTTP, and make sure it is turned on. Okay, then we'll close that out and connect the Eagle server FA0 port. Connect the Eagle server to the FA0 port on the R1 router. Okay, going between a server and a router, both have a processing unit. So I would use a crossover. we'll go from the Eagle server to R1 FA00. Let me make sure. Yes, it did say 00. Okay, PC1A has lost its IP address information, so we're going to go configure it with the following. I think the easiest way will be from desktop IP configuration. And we'll set the address to 172.16.1.1. Subnet mask needs to be fixed. No, it can be left like it is. Our default gateway, 172.16.254.253. Nope, sorry, it's 255.254. I was looking at the one up here instead of the one down here. I need to make sure I get the right one. And my DNS server, 192.168.254.254. I should know its address, I just configured it. Okay, then we're done there. And we're going to connect from the PC to FA01 on the switch. So between a PC and a switch does not have a processing unit, so we would use a straight through. Okay, now we can verify our work using check results. And I can tell we're done because it says congratulations. And we got all our check marks. And I'll close this window. And I'm going to come back to my activity. And now they want me to test connectivity in real time by using a add simple PDU from PC1A to the Eagle server. All right, so I'm going to expand my window. And down here at the bottom, you'll see this arrow on the right hand side. So you click that and it expands your real-time window. Okay, now if you want it bigger, you can actually toggle it and put it up top. And I can create new scenarios and I can delete my old scenarios. All right, so I'm ready to add a simple PDU. So I'm going to click over here on the right side, the envelope with the plus sign, not the one that's open. That's a complex PDU. We want a simple PDU from PC1A to the Eagle server. Now, yours probably failed. That's from Address Resolution Protocol. Come do it one more time. And it should be successful. Okay, then I want to delete these because I'm about to go into simulation mode. To explore DNS, UDP, HTTP, and TCP working together. Okay, so I'm going to switch from real-time mode to simulation mode. And I'm going to edit my filters because in this case, a couple are turned on I don't want. So I'm going to go edit filters. I want DNS. I do not. Oh, I do want ICMP. How did I miss that? And I want HTTP, TCP, and UDP. So I turned off the LLDP. I don't see where we need it for this exercise. Okay, so now I can double check DNS, UDP, HTTP, TCP, and ICMP. Okay, if you don't know what these acronyms are, then you need to go back through chapters 3 and 4 and pick up what those particular protocols are and why we're looking at them here. Okay, we're going to open PC1A or click on it and go to the web browser. And on the web browser, we're going to tell it to go to the Eagle server. I do believe. Yes, eagle-server.example.com. Okay, and now we can use the capture forward. So I'm going to actually expand this window. And you can see right now that that packet is a DNS type. The DNS client is sending a DNS query to the DNS server. All right, before it gets to the server, because we're not directly attached to the server, it's got to go to the switch, and then to this router, and then to this router, and then to the server. Okay, so right now, layer 4, the device encapsulates the PDU into a UDP segment. Its destination port is 53, source port 1025. At layer 3, the source IP address is not specified. The device sets it to the port's IP address. The destination IP address is not in the same subnet and is not the broadcast address. The default gateway is set, and the device sets the net's top to the default gateway. So see, if you don't have a default gateway, you're not getting out. You don't have any way to get out. So the default gateway being set, and then that's our next hop. That's where everything goes before it goes out. At layer 2, it looks at the next hop IP address. It's a unicast. The ARP process looks it up in the ARP table. And the next hop address is in the ARP table. The ARP process sets the frame destination MAC address. See your MAC address in there. The device encapsulates the PDU into an Ethernet frame. At layer 1, the port sends out the frame. We can look here and see the source MAC address should actually be the MAC address for the switch, because at this point we don't know what it is for the Eagle server. But it is picking up. Notice the source IP address here in the IP frame. That's how we track where information comes from. UDP is looking at the source port and the destination port. And the DNS query, here's our eagleserver.example.com. Okay, so that's as the packet is leaving PC1, headed on its journey to the Eagle server. It hasn't even left yet. It's getting ready to leave. So now as we hit capture forward, it'll capture what it was doing there and forward it to the next place that it's going. Okay, now the packet's here. And look, we only have layer 1 and layer 2 information at that time. Switch is a layer 2 device. That's why there's only layer 1 and layer 2 information there. All right, on the incoming layers, we have the fast Ethernet header. It comes in on 01. It knows to get there, it's got to send it out 024. So the outgoing layer is 024. We can look at the incoming frame as it's coming into the switch, what it looks like. And we can look at the outgoing information and what it looks like once it gets ready to send out. Okay. So I'll continue the capture forward process and examine each packet one at a time. Now, kind of speed things up. Packet gets back to PC1. Here's what that looks like coming into PC1 from the Eagle server. Okay. All of that should help answer the reflections. This we can work on as a group and class if need be. Make sure you get a screenshot of your check results window with all your check marks. Submit that to the Wheat2 Packet Tracer Lab Dropbox.